Intro Algebra Lesson 2-3B. We've been working on taking subtraction problems and converting them into addition problems. And if you recall, that means that anytime we change subtraction into addition, we must change the sign of the number that directly follows that subtraction sign. Now today, we want to look at the idea of terms. And terms, when we're dealing with an expression, remember that's not with an equal sign, although equations are made up of expressions on both sides, are written as a sum. The terms would be the parts that we're adding together. In other words, the chunks of an equation that are being added together. For example, if you had the expression 4 plus x, this would be one chunk, the 4, and this would be another chunk, the x. These would be the parts that are being added together. So the 4 and the x are considered the terms. In 3x squared plus 2x, this is a chunk that's being added to this chunk right here. So 3x squared is one term, and 2x is another term. So if you think about it, just remember, terms are the parts being added. And since we can change subtraction into addition, any addition or subtraction expression, we would have terms. Now, when we have terms, if we have what we call like parts or like terms, then we can actually combine those terms. And we deal with the same exact rules, the adding and subtracting of positive and negative numbers, as we had without the variables on them. Since this has an x and this has an x, these are considered like terms or like parts. We will still practice what we've been practicing, which is to change this to addition. And if you change that, then the sign must follow, it has to change as well. So now you're dealing with a positive 9x and a positive 8x, which is going to make a total of 17 x's. Recall that on a number line, if you subtract a positive, you go to the left. If you add a positive, you go to the right. So subtracting a negative can't be the same as subtracting a positive. Subtracting a negative must also go to the right, which is why adding a positive is exactly the same. This would be the same as adding a negative. So adding a negative is the same as subtracting positive, and subtracting a negative is the same as adding a positive. Alright? Again, we want to get in the habit of changing subtraction, so here we're going to go plus positive. Now that we have plus positive, we ask ourselves, do we have more negative r's or more positive r's? And the question is, we have more positive r's. We have two more positive r's. Okay, now with decimals, it doesn't really matter. It's the same thing as before. We're going to deal with the decimals in front just like we would any other moment. But we'll change this to plus negative 13.5d. Now you got to be careful because there's a real habit for people to do up-down subtraction. People like to take 13 and subtract the 7 and get a 6, but then they want to take 8 and subtract 5 and end up with a 3. That's a really common mistake. We're supposed to ask, do we have more positives or more negatives? The answer is we have more negatives. Now this is what I'm talking about in terms of being careful. People will take it and they'll go this way, 13 minus 7 is equal to 6, and then they'll go 8 minus 5 is equal to 3, and they go, oh, the answer is 6.3. You can't do that. That will not work. That's what I call the up-down. You're going two different directions with your subtraction just because it's easier in your head, and it doesn't require you to borrow that way. You must take what you have more of, which is 13.5 negatives, put what you have more of on top, and subtract what you have less of. Now you can borrow. You'll have 12. 15 minus 8 is 7. Bring your decimal straight down. 12 minus 7 makes 5. There's a big difference between 5.7 and 6.3. Our answer is negative 5.7. So be very careful that you don't end up doing this type of subtraction. This will be wrong. It's a very typical mistake that people make when they want to do subtraction as quickly as possible and easy. You got to be careful about it. Alright? Now there's more going on in this problem. You'll notice that there's a 2g minus a negative 5, and then there's a negative or a subtractant of another 8g over here. We would love it if we could take this G and this G and put them together, but they're not right next to each other. And we don't want this one doesn't have any G's, so it can't be combined with either of these. It doesn't have the same parts. Now, as it stands with subtraction, we're kind of locked. We can't do very much. But because we have the addition of the opposite here and the addition of the opposite here, we can now turn it into an addition problem where we have the commutative property. We can rearrange it in any order we want, which means I can make this 2G plus negative 8G plus a positive 5. Notice all I did is switch the order of these two, and now I have the G's right next to each other. That's the advantage of addition over subtraction. Now 2G plus negative 8G, I've got more negatives than positives. I have 6 more negative G's than the positives. At this point, that's as simple as it's going to get. Unfortunately, what some people do is they try to take a step further and they say that's negative 1G. Or maybe they mess up with the signs and say it's negative 11 or positive 11G. This has a G, this does not have a G. You cannot go this far. They can only be added or subtracted if they have the same parts, the same variables. Last example. Now we've got some W's and we have an absolute value symbol here. I want to caution you with the changing of subtraction. It's a big habit of ours to change subtraction to addition, but if there's a grouping symbol like this that's an absolute value bracket, you cannot do this. You can't do it. You must first take care of the absolute value. Once you've taken care of the absolute value brackets and they're gone, then you can change the subtraction to plus the opposite. This W over here, how many W's are there? There's only one W right there, so you can put a 1 in front of it if you like, which will be nice because it'll work well there. Now, as far as the absolute value of 7 is concerned, the absolute value, how far it is from 0, 7 is 7 units from 0. So negative 4W minus 7 plus 1W. Notice all I did was get rid of the absolute value brackets by finding the actual absolute value of 7. Now, this subtraction I can change. I'll make it plus negative. And because it's addition, I can add in any order. I can now put negative 4W plus 1W plus negative 7. And since these are like parts here, I must ask, do I have more negatives or positives? I have more negatives. How many? 3 more negatives. And that's as far as it goes. This does not make negative 10W. This does not have a W, so it cannot be combined with it. Alright, so that's practicing more with the positive and the negative numbers, decimals, but making sure that we also deal with the variables. They have to have like parts, because if they don't have the same parts like right down here, then they can't go any further, even though that's a very typical mistake.